and welcome to Tech presented by Kaizen, where we will explore common cleaning questions and answers. This session has been pre recorded and will include additional FAQs related to this topic. Let's get started. I would like to introduce Kaizen's own Will Sweet.
Thanks, Sherry, and thank you everyone for attending for what will be a short talk on adding corrosion protection capabilities to your vacuum degreasing process. Again, it's probably going to be 10, 15 minutes long. This is all going to be an effect. It's going to be teaching you an effective way to keep your parts lasting longer, assuming that you are in fact using a vacuum degreaser. So on the agenda for today, I'm going to start off with a brief introduction to vacuum degreasing, just making sure that we're all on the same page. Then moving on to the bulk of this presentation, which will be adding corrosion protection capabilities to your vacuum degreaser. And finally, we're going to end with monitoring. And essentially, for the most part, that's monitoring the concentration, the condition of your corrosion protection product while it is in your vacuum degreaser over time. So starting off with vacuum degreasing. So why did vacuum degreasing come to be at all? And it really was just because of this large move to environmentally clean cleaning processes, moving away from what a lot of people refer to as the fun solvents, as PERC, TCE, and NPB. Very good cleaning solvents, but weren't very safe for the environment or for users. So yes, moving away from these open organic solvent systems, these open top vapor degreasers, I'm sure many of you all are familiar with. And again, that's due to the VOC emissions that these systems and solvents had. And moving toward organic solvent closed systems, and that's what these vacuum degreasers are. They're closed, sealed systems that are using solvent. And moving towards a safe halogenated fluorocarbon solvents, so the modified alcohols and the hydrocarbons, those are the different types of products that go into these vacuum degreasers. And then aqueous cleaning isn't going to be going anywhere anytime soon. There are a lot of cleaning applications and specs that call for aqueous cleaning specifically, and it definitely does do a job. Um, and whether that's a good or a bad thing, I happen to like aqueous cleaning as well. It's not going anywhere anytime soon. Some of the benefits of vacuum degreasing: it's a great cleaner for both polar and non-polar soils. Able to meet a wide range of cleanliness specs. No water is required. Again, it is all just solvent and potentially CP products that are going through these systems. None of those are HAP. They're non-HAP solvents. Low VOC emission process. Again, like I mentioned earlier, this is a sealed machine. It's not like the old vapor open top vapor degreasers. And these systems have the potential for great rust prevention and protection capabilities, which is what the rest of this presentation is going to be going over. Finally, these systems are they have a very efficient use of solvent. So you're reusing solvent and oil actually. So the solvent that you're charging the machine with, it's actually going to be recycled, and you can be using that same solvent over and over again to clean more and more parts. Um, and low consumption. I do want to spend a second here because it is not no consumption. You will have some evaporative loss whenever you're putting parts in or taking parts out and little things like that, but it is very low. And because of this recycling and this very low consumption, it ends up in a pretty low cost process. So this is just a model of basically what a vacuum degreaser looks like, the inner workings of one. So the work center, the wash chamber in the very middle of the chart, that is actually where the parts go in and out. That's where all the magic happens, where the solvent is flushed into, and it's where all of the cleaning is actually done on your parts. And typically, it's coming out of tanks 1 and 2. So tank 1 is where the dirty solvent is flushed in, dirty in quotations, and it's going to do the bulk of the cleaning, and then you're going to have a final polish with tank 2. Then, of course, there's the still and condenser. This is just a big distillation process. And through the pump, it goes through a filter and ultimately into the still. This is how you're able to continually reuse the same solvent. So it's going to continually clean up the solvent in the still. It's going to condense back down and come back into tank 3 or tank 2, depending on the setup of your vacuum degreaser. Um, and then you start the process all over again. So it's just with clean solvent, you're able to continue going back and forth with new solvent. And then adding corrosion protection. So this is the meat of today's presentation. This is obviously just a picture of some rusty screws. anyone in metalworking, anyone making parts, I'm sure has run into rust issues once or twice in their career. So, especially in the hot summer months and the humid months, currently I'm in one of those hot summer months right now. The rust, you're even more susceptible to rust in those conditions. So, this is a this presentation is about preparing and helping to decrease those instances of rust in your process. Here's another diagram um, of one of these vacuum degreasers. I want to draw a little bit more attention this time to tank number 3. That is where these CP products, these rust prevention products, are going into. And I'm sorry, I'm going back and forth between CP and RP. It is synonymous. CP for corrosion protector and RP for rust protector. Um, it is also worth noting that diluted amounts of these CP-based products are based off of total volume of the machine. So say that this whole setup right here is a 100-gallon system. If you're going to be running your CP product at 3% concentration, you're going to need to put 3 gallons of your CP product into tank 3. And then the process just works just as normally with the CP added. Whenever the CP step starts, when you can set those on the machine interface, it's going to funnel in all of the material in tank 3, and that's going to include the 3% mixture of CP. So these CPs are all wax-based. They're wax-based products. There's that separate RP tank, the tank 3 that I was just talking about. And it is so we find that our customers find success anywhere between 3 and 7% for the most part for most applications. And concentration is is controlled with NVR percentage, non-volatile residue. Um, It's also so going back to this 3 to 7% concentration, it really depends on how long of protection you need, what your everyday warehouse work conditions are. It really is process and environmentally dependent. If you have a good air conditioned area where the parts are going to be held for the duration of their stay, I mean, we've seen 3% get people 60 to 90 days, something like that. So it really depends on what your current conditions are. Um, Lastly, it's worth noting that after you apply one of these RPs through a vacuum degreaser, do not clean them in a traditional open top vapor degreaser after that. Most of those solvents are designed to remove wax-based materials, and these CPs are, in fact, a wax-based material. So, concluding with monitoring the RP in your tank, I mentioned NVR, non-volatile residue. That's how we recommend tracking your concentration over time. What you see here is literally just a small oven. There's different names out there, different types, brands, moisture analyzers, things like that. Um, the whole process in and of itself is essentially just putting a sample of solvent into one of these small ovens and evaporating everything off that you can. And what's left over is non-volatile. It's that NVR percentage, and based on that weight and how much is there, you're able to tell how much corrosion protection or corrosion protector product is in the machine and what concentration that you're running at. So here is a chart right here where you can do that. After you do put the sample into the small oven and you evaporate everything off, say that there is 1% NVR left, go to the one on the left and take it all the way to the right. You're sitting at almost 3% concentration in your system, if that is the NVR percentage that you find. So moving on to some FAQs, some of the frequently asked questions. How long will the CP product protect my parts? I alluded to that a little bit earlier as well. Um, and it really is situational. It depends on your situation. We've seen 3% get people 60 to 90 days, but say that your warehouse isn't air conditioned, you might have to go with a higher concentration. We've seen people go all the way up to 7%. I mean, even 8, 9%, there may be diminishing returns after that 7% mark. But again, it is a little situational dependent and will probably take some optimization on your part. Moving on, where does the CP left on the tank walls go? So yes, this wax-based material, after it is funneled through onto your parts, the wax is left on your parts to protect them. So it's only logical to assume that that wax is also going to be left on the tank walls inside where the CP product is flushed into. And eventually, the answer to that question is it leaves the system kind of like oil does. Eventually, it's going to be flushed and go through the piping and make its way to distillation and then be dumped out with the oil. That's where the CP eventually will go that builds up on the tank walls. Then does the CP leave a wet film behind on the parts? The answer to that question is no. It is actually a dry paraffin film that is left on the parts. Um, So it is not oily. At 3%, a lot of times you can't even see that dry film. But I mean, if you're getting higher, 7, 8, 9%, you probably will be able to see that film. But again, it is just dry. It is not a wet dripping film. And finally, why would you not go with a pure wax CP? That's a good question. In fact, most of the products out there are diluted with a similar material to the solvent that's actually cleaning the parts. And so, roundabout way to answer that. The reason for that is because if you don't do that, it's actually the wax is going to have to be melted down on the floor. So it's going to be more manual labor for the customer, for the end user. It's going to have to be melted down. And you run into the danger of actually clogging the pipes in your system if you have this raw pure wax going through the pipes, especially on some of these auto addition systems. Those pipes aren't heated, so eventually it's going to cake up there, and it's not going to be able to be moved throughout the machine. It's going to take some more maintenance on your part. So that is all I have for you today, and I'm going to turn it back over to Sherry.
Thank you, Will, and thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to feature content sent directly to your inbox? Or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.